Welcome all to the introductory session to cloud computing. Cloud computing is the latest technological buzzword doing rounds in the business world these days. Many businesses are turning to the cloud. In fact, Gartner predicts that the worldwide public cloud services market is forecast to grow 17% in 2020 to total $266.4 billion dollars, that is up from $227.8 billion dollars in 2019. At this point, cloud adoption is the mainstream, said Sid Nag, research vice president at the Gartner. The expectation of the outcomes associated with the cloud investments, therefore, are also higher. Adoption of the next generation solutions are almost always cloud enhanced solutions, meaning they are built on the strengths of the cloud platform to deliver digital business capabilities. In this session, we will talk about what is the cloud computing, what are the benefits of the cloud computing, why different organizations are migrating from traditional IT systems to the cloud system, what are the different types of cloud service models, what are the types of clouds. Then we will cover the introduction to AWS cloud service, what are the different services provided by AWS. We will discuss one of the sample deployment model using different AWS services. Then we will discuss what is the basic concept behind the AWS pricing, and at the end we will discuss some of the basic concepts used in AWS to understand the vastness of the AWS cloud services. So now we will discuss what is cloud computing. So cloud computing is an internet-based computing service in which large group of remote servers are networked to allow centralized data storage and online access to computer services or resources. Using cloud computing, organizations can use shared computing and storage resources rather than building, operating, and improving infrastructure on their own. Cloud computing is a model that enables the following features. User can provision and release resources on demand. Resources can be scaled up or down automatically depending upon the load. Resources are accessible over the network with proper security. Cloud service providers can enable a pay as you go model where customers are charged based on the type of resources and per usage. So now we will discuss the benefits of the cloud computing. We can categorize benefits of the cloud computing in four major categories. One is the agility, second one elasticity, third one is the cost saving, and fourth is the deploy globally in minutes. In terms of cloud computing, elasticity is defined as the degree to which a system is able to adapt to the workload changes by provisioning or deprovisioning resources in an automatic manner, such that each point in the time the available resources matches the current demand as closely as possible. So if we say generally we can map it to the auto scaling feature provided by different vendors. Similarly, agility often refers to the ability to rapidly develop, test, launch software applications that drive business growth. Third one is the go global in minutes. It is the easy deployment of your application in multiple regions around the world with just a few clicks. This means you can provide low latency and better experience for your customers at minimum cost in minimum time. Last benefit is the cost saving. With cloud, we need not to plan for servers and other IT infrastructures which takes up much of the time in advance. Instead, cloud services can instantly spin up hundreds or thousands of servers in minutes and deliver results faster. We pay only for what we use with no upfront expenses and no long term commitments, which makes cloud services cost efficient. So, it's not just the benefits, so there are certain disadvantages of the cloud computing also. So, one of the biggest disadvantage of cloud computing, even though it provides a wonderful set of advantages, is the security concerns. Security is a major issue in the cloud computing. The cloud server providers implement the best security standards and industry certifications. However, storing data and important files on the external service providers always bears a risk. Now we will discuss why organizations across world are moving from traditional IT systems to cloud. Here, traditional IT systems refers to on-premise data centers or hardwares which are generally maintained and managed by organizations' technical professional teams. In traditional IT systems, there is an upfront cost of infrastructure, that is capex, which further takes time, in some cases up to months or weeks, to procure and provision the hardware. The overall ownership of data centers also increases as running traditional data centers includes cost of hardware, software, disaster recovery arrangements, uninterrupted power supplies, and networking. There are also other expenses or components of cost which includes heating, air conditioning, property and sales tax, and labor cost. In the case of cloud data centers, the OPEX, that is the operational expenses, are variable because of pay as go principle. Customers get the latest and emerging technologies, including hardware as well as software. There is a ease of implementation, that is just a few clicks and the application can be deployed without worrying about the hardware and software procurements. In cloud data centers, there are 10,000 or more servers on site, all devoted to running applications that are built with consistent infrastructure components such as racks, hardware, OS, networking, and so on. Cloud data centers are constructed for different purpose, built to different scale, perform different workloads than traditional data centers. Because of this design approach, the economics of cloud data centers are significantly different. Now, these days, many businesses are turning to the cloud. For many businesses, utilizing the cloud makes sense. Large enterprise organizations with limited budgets and startup businesses with lack of resources may find that the cloud is a good option for them because it gives them immediate capacity without the need for a big upfront investment. Other organizations may find that the cloud is useful for the disaster recovery processes. Now we will discuss the different cloud service models. So there are three different cloud service models. First one is the infrastructure as a service, which we call IaaS. Next one is the platform as a service, which normally we call as a PaaS. Third one is a software as a service, which we generally call SaaS. So if we compare it with the on-premise data centers, which are generally managed by customers, where right from networking to storage, servers, virtualization, operating system, middleware, runtime, data centers, applications, everything is managed by the customer itself. So, if we talk about the infrastructure as a service, it provides users with the capability to provision processing, storage, and network connectivity on the demand. Using this service model, the customers can develop their own application on these resources. Networking, storage, servers, and virtualization is managed by vendor, whereas operating system, middleware, runtime execution, environments, data, and application are managed by customers. The examples are AWS, Azure, Google Cloud Platform, Alibaba Cloud. If we talk about the PaaS, which is a platform as a service, here the service provider provides various services like database, queues, workflow engines, emails, etc. to their customers. The customer can then use these components for building their own applications. The services, availability of resources, and data backup are handled by the service providers that help the customer to focus more on their application's functionality. In this case, vendor manages network, storage, servers, virtualization, operating system, and middleware, whereas customer gets the runtime environment to run his applications. The examples are AWS Elastic Beanstalk, Cloudbean, Cloud Foundry, Google App Engine, etc. If you talk about the SaaS, which is basically a software as a service model, in this, as name suggests, here the third party providers provide end users applications to their customers with some administrative capability at the application level, such as ability to create and manage their users. Also, some level of customization is possible, such as customers can use their own corporate logos, colors, etc. In this model, everything including the application is managed by vendor and client just uses it to perform his task. One of the example is Gmail service. Now we will discuss different types of clouds. So there are three types of clouds. First one is public cloud, second one is the private cloud, and third one is the hybrid cloud. So in public cloud, the third party service providers make resources and services available to their customers via internet. Customer data and related security is with the service provider. So advantages of public cloud are these are low cost, on-demand scalability is there, but you have to like now we will discuss some of the basic AWS services which are being used by many organizations across the world. So first one is the EC2, which is the Elastic Compute Cloud. It is a web service interface that provides resizable compute capacity in AWS cloud. It is designed for developers to have a complete control over web scaling and computing resources. So if we try to understand, it is a virtual machine which configure, you can ask for number of cores, RAMs, and type of storage data, and everything, all the configuration can be simply done using the AWS console or web interface. Then another service which is widely used is the Elastic Load Balancer. So it is used to spearhead the traffic to web servers, which improves performance. AWS provides a elastic load balancing server service in which traffic is distributed to EC2 instances over multiple available zones. and dynamic addition and removal of Amazon EC2 hosts from load balancing rotation. So it's basically a kind of a load balancer. So whenever traffic comes to load balancer, it checks the health of nodes which are attached to the load balancer, and based upon the algorithm, it distributes the traffic to the nodes. Then next service is the CDN, which is the content delivery network, which is basically also known as a CloudFront. So it retrieves data from Amazon S3 bucket and distributes it to the multiple data center locations. It delivers the data through the network of data centers called edge locations. So what happens normally when you have a data which is located in a one region, and if somebody tries to access the data from another region, then due to the uh, latency of the data, so basically that data has to come from that region to another region, and it has to be served to the customer. Again, next user from same region tries to access that data, again there is a same latency. To overcome these kind of limitations, AWS has a content delivery network where edge locations are present throughout the world, and whenever a customer tries to fetch a data that is cached in the nearest edge location, so it helps in basically reducing the time latency of data. Then next service is the EBS, which is the Elastic Block Storage. It is a block storage system used for storing the persistent data. Amazon EBS is suitable for EC2 instances by providing high available block level storage volumes. It has three types of volumes: general purpose, which is the SSD, provisional IOPS, which is the SSD, and magnetic tapes. These three volume types differ in performance characteristics and obviously cost. Then next service is the Amazon Virtual Private Cloud, which is VPC. So VPC allows users to use the AWS resources in virtual network. Users can customize their virtual networking environment as they like, such as selecting own IP address range, creating subnets, configuring route tables, and network gateways. The next most commonly used service is the Route 53. Route 53 is a highly available and scalable domain name service, which is basically a DNS web service. It is designated for developers and corporates to route the end users to internet applications by translating human readable names like, uh, for example, www.mydomain.com into the numeric IP address like 192.0.2.1 that computer uses to connect to each other. Next service which we can cover is the Amazon RDS, which is Relational Database Service. So it is a fully managed SQL database cloud service that allows to create, operate relational databases. Using RDS, you can access your files and database anywhere in a cost-effective and highly scalable ways. So these were the very commonly used services. So there are many other services also, like you have the NoSQL databases, then you have SNS for simple notification service, then SQS is there, which is the one of the first AWS service uh, you know, created and developed by AWS. Then you also have multiple monitoring services and so many things. Before starting with AWS, let's start understanding what is AWS, how it started, how it was conceptualized, how it has grown into such a big name in the cloud computing. The AWS platform was launched in July 2002. In its early stages, the platform consisted of only a few disparate tools and services. Then in late 2003, the AWS concept was publicly reformulated when a paper was presented by some engineers of Amazon, and they described a vision for Amazon's retail computing infrastructure that was completely standardized, completely automated, and would rely extensively on the web services, such as web service for a storage service, and would use internal work which was already underway. Near the end of the paper, they mentioned the possibility of selling access to the virtual servers as a service, proposing the company that this could generate revenue from the new infrastructure investment. In November 2004, the first AWS service was launched for public usage using the SQS, which was a simple queue service. Thereafter, Amazon Web Services or AWS developed three more services, and they relaunched it again on March 14, 2006, consisting of Amazon S3, which was a cloud storage, SQS, and EC2, which was compute service. The AWS technology is implemented as server farms throughout the world and is maintained by AWS subsidiary. Fees are based on combination of usage, that is hardware, OS, software, networking features, which are chosen by subscriber. Subscriber can pay for a single virtual AWS computer, a dedicated physical computer, or a cluster of either. As a part of the subscription agreement, Amazon provides security for the subscriber's system. AWS operates from many global geographical regions. As we have already discussed, Amazon Web Service is a group of web services, uh, correct? And it is the most broadly adopted cloud solution in the world as of now. Its data centers are spread across globe. It provides infrastructures like CPU storage as a service, as a most likely like its web services, and it provides highly reliable, scalable, low-cost infrastructure platform. Now we will discuss one of the AWS Basic Deployment. So this is the pictorial view of fault-tolerant architecture using the AWS global infrastructure. So if we see here, we have a two different regions. One region is EU West 1, and on the right it is the second region is US East 1. So in each region we have configured EC2 instance that in a such a way that we have a one EC2 instance running in each availability zone. So EU West 1 has two availability zones, and US East 1 also has a two availability zones. We also have configured the relational database in a such a way, we have a master and slave configuration. Okay, and then we have a routing based upon S31. So, and each region we have a load balancer which basically distributes the loads to the EC2 instances in each availability zone based upon the algorithm. So this is one of the high level AWS fault tolerant architecture. So in this case, what happens, like, if one of the uh, say region goes down, then whole traffic is basically uh, routed to the another region by the routing, or basically we can say router. Similarly, if one of the availability zone goes down, then in we the whole traffic basically is taken care by load balancer, and traffic is routed to the uh, availability zone which is up. And based upon the master slave configuration, so like if master goes down, then standby basically takes up the position of master and start serving the EC2 for database requests. So here we will discuss the AWS pricing. So as we have already seen, AWS has a low variable cost where, like, you only pay for what resources you consume. So there are multiple pricing models for different services, but here we will discuss the basic core components or core fundamental characteristics which AWS internally uses to calculate the price. So if we see, then we first one is the compute, which is server hours, which is calculated in terms of hours. Then we also have compute uh, price calculated based upon how many cores you are using, what type of OS is it. Like, for example, Windows, it may have a licensing cost. For Ubuntu, it may be free. Then how much RAM you require, how much local storage you want, whether this compute node is on demand, is it a dedicated, is it a reserved, or is it a spot instance. So all these factors, they are considered while calculating the price for compute. Then for storage, what type of, there are different types of categories of the storage type. So uh, based upon types, the prices are calculated. Then how much storage you use, correct, and based upon the performance, like how how many input output operations per seconds you want, that also qualifies for the uh, calculating the price of storage device. And next one is the data transfer. So as per the AWS, there is no charge for inbound data, but whenever data is transferred out of the AWS, that is used for charging the data transfer. Similarly, bandwidth aggregated across all the services, that also is used for calculating the data transfer. So if you go and see AWS, you won't find this kind of a characteristic differentiation of pricing of AWS. But all these three basically combines together and combines together for calculating the price of AWS. Let's say, for example, if we want to uh, host a database. In case of database, processing power plus storage plus transfer rate, all three different factors basically they will be combined together to calculate the price of a uh, database resource. Okay, so there is also one application which AWS calls a calculator. So I have shared this link. You can go through this link, and this will help you to estimate the cost of your architecture solution. So for example, as we discussed earlier, we have shown a sample architecture, correct? Uh, and if we just try to go deeper into and say like we want a 4 core processor with a nano core, and we want to have a 16 GB of RAM and those kind of a configuration, if we have it on a paper, then we can use this calculator to check what would be the estimate cost of your solution or your set of resources. So this helps in calculating or getting a rough price, like uh, what would be your final bill. Let's discuss the basic concepts of AWS, that is the regions and availability zone. As of 2020, AWS has distinct operations in 22 geographical regions spread across the globe. AWS has announced 5 new regions that will be coming online in Italy, South Africa, Spain, Osaka, and Indonesia. AWS is serving 245 countries presently. Each region is completely contained within a single country, and all its data and services stays within the designated region. This helps in achieving the data privacy rules of many countries, which restricts data transfer out of the countries. Each region has multiple availability zones, which consists of one or more discrete data centers, each with redundant power, networking, and connectivity housed in separate facilities. Availability zones do not significantly provides additional scalability or redundancy within a region, since they are intentionally isolated from each other to prevent outrage from spreading between the zones. As of now, there are 70 availability zones, and this number keeps on increasing. Several services can operate across the availability zone, that is S3 and DynamoDB, while other can be configured to replace the zones to spread demand and avoid downtime from failure. A local zone is an extension of a region that is different location from your region. It provides a high bandwidth backbone to the AWS infrastructure and ideal for the latency sensitive application, for example, machine learning. This is the pictorial view of the AWS regions and availability zones spread across the globe. As we can see, there are 16 regions and 42 availability zones and 68 edge locations. These numbers keeps on changing, so you always need to refer back to the AWS for correct information at a correct time. So if we see, AWS has two regions specifically reserved for the AWS government applications. Similarly, AWS has Oregon region, which has three availability zones. In North California, there is one region which again has a three availability zones. And if we see in Mumbai, they have one region which contains two availability zones. Similarly, there are certain new regions coming up. So one is in Paris and some other, as we discussed in previous slide. So there are 68 edge locations. Edge locations, as we discussed earlier, these are the near shore So this is the end of this introductory session on cloud computing. Thank you everybody. I hope you all enjoyed this session. In case of any queries, please do connect to us on edevguru.com.